Good morning to all of you. So, in our last lecture on center of mass, we have studied the basics about the center of mass. And there we have solved few problems and they were of simple type. But today, this is our second lecture on center of mass. And today we will solve few problems. And these problems are solved using a special technique which is very important. That technique is double integrals. So we will learn how to use double integrals in solving the problem of center of mass. So let us see what we are going to do today. We will be solving three problems. The first problem is a rectangular sheet, and here the sigma is changing. The second is a triangular sheet of thickness T. Thickness T means small thickness T. It is not a very thick, thin, but thickness T. Here the sigma is constant. So here we will see that how we can convert a two-dimensional, three-dimensional problem to two-dimensional problem. The third, we will take up a region under parabola. Okay. And here also sigma is constant. We will be solving using three different methods. The fourth method we will see is not so correct, but we will be solving using three different methods. Alright. So let us see the first problem. In the first problem, the question is that we have to find the center of mass of a rectangular sheet. This is a rectangular sheet. The length of the sheet, as you see, is A and the width is B. Now, this particular sheet, the main important point about this problem is that its sigma, that is mass per unit area, is changing. It is not constant. It is changing with x and y. That is why this problem is important. Otherwise, this is a very simple problem. Now, when sigma is changing, then as you see, the mass is not uniformly distributed. So, we have to calculate the capital M also. Now, in all our problems, what we have seen, that first we calculate the, first we see what actually our dm is. So, the dm, for that dm, we choose a small incremental area, a mass dm, having its dimension dx along x and dy along y. So, this is a small mass dm in that sheet, and the distance is from the O is r vector, that is your position vector of this small mass. So, dm, as you see, it is sigma dx dy. Now, we have to integrate to get the capital M, that is the mass of the sheet. So, integral dm is sigma dx dy. X is varying from 0 to a, and y is varying from 0 to b. So, this is the integral. Now, the first time that we see that while integrating, here both dx and dy are there. Both dx and dy are together. So, it is not a very simple integral the way we have done before. It is a double integral because both dx and dy both are changing. So, how to handle this double integral? So, this is the first example and the simplest example where we will see that how we can handle this double integral. So, what we do here is, let us see, what we do here is that in these double integrals, first of all, we take either one of them, that is, either you take x or you take y. First of all, suppose say here, we integrate over x first, and then when we integrate over x, the y is taken constant. Then we do the reverse. That is, we integrate y at that time, though x, if it is there, so x is remains constant. But x is, after putting the limits, so only y will be there. Otherwise, you can do the reverse way also. That means you can integrate over y first and then you can integrate over x. So if you are integrate over y, then x will remain constant. Now let me explain a little bit more that what is that we do. Now suppose say you integrate over x, treating y is a constant. Now when you treat y as a constant, what will happen that if you extend this as a line, so this is a kind of strip that you will be integrating. So whole integral will be integrated along this strip. Okay. Then you integrate, so then you put the limits of x, and when this is taken care of, that means you have integrated over this strip, then you put the limit of y. So that is how you find out the integral, the whole integral. I hope this is clear. Now let us see how to do it. So m is sigma dx dy. So let us substitute sigma. Sigma is sigma 0 xy by ab, sigma 0 xy by ab dx, and then dy. So what we do for this particular case, you can do it otherwise. We take integrate over x first. So we take this integral, that means xy ab dx. So this is within this bracket. Okay, this is the first bracket, or I have written 1. So this we have taken within this bracket. So this is the first one that we will be integrating. Now the dy I have kept outside. When you integrate this one, then y is taken constant, and that is why I have written constant in 1. What are the constants in 1? So obviously sigma 0 ab will be constant, but y is also a constant. So first of all, you integrate x, keeping y as a constant. When that is being integrated, then you go further to integrate dy. At that time, x anyway, after the putting the limits, x will go away. But that is how we do it. Okay. So let us see. We have already integrated So we have just written like this, and now you integrate x, that is x is equal to varying from 0 to a. You integrate that, x square by 2. You put the limits dy. Then you integrate y dy. Is this clear? Y dy. So 0 to b. Now after the integration, this is the answer you get, sigma 0 ab by 4. So you have got the total mass m. Total mass m of the sheet, you have got it. So let us underline this. Sorry, this is the one. Well, now what we do, we calculate the center of mass. Now center of mass, that is your vector r, is 1 over m r vector dm. This is what we have studied in our last class. So r vector is capital R vector 1 over m small r vector dm. Now small r is the position vector of that small mass. So that I have written x I cap plus y j cap, small mass. dm is sigma dx dy. So 1 over m x sigma dx dy I cap. So what I do, I separate I cap and I separate j cap and write these two expressions separately. Then I write this as capital X and capital Y. Because this is the way, if we do it, it is easier and you will not make mistake. So this is the x component of the center of mass and this is the y component of the center of mass. So let us calculate the x component. So 1 over m, the same 1 over m x sigma 0 xy by ab, expanding sigma, substituting that sigma 0 xy by ab dx dy. Then again what I do, that I integrate x first, but you can do otherwise also. So integrate x first, that is your x square dx, limit 0 to a dy, and here we integrate x and then dy. Then once x is integrated, we integrate the y. So it is 2 by 3 a. So this is your x coordinate. Exactly the same way you can calculate the y coordinate. So finally the center of mass, you get 2 by 3 ai plus bj. So this is your final answer for this particular sheet. Now I have been telling this, that can one integrate over y first and then x? Surely, why not? So yes. Fine. So this is the first example that we have studied of a rectangular sheet where the sigma is changing, and we have calculated the center of mass using the double integers. Now what I suggest, that you just go through it once again, and maybe you take a glass of water by the time we start the second problem. Good. So after our question number 1, problem number 1, the problem number 2 is a solved example from Clipner. Let us see what is the problem. The problem is, find the center of mass of a right triangular sheet of mass capital M, base B, height h and small thickness t. So here as you see, it is a small thickness t. It is a 3D problem. But this 3D problem, we can change it to 2D problem. Here rho is constant. It is simpler in that case from the first problem. If rho is constant, we don't have to calculate the mass. Otherwise, we have to calculate the mass as well. Okay. So let us see. It is a triangular sheet. Base B, height h and thickness t. Rho is constant. Here what we do, we take small, again the small mass we have to consider, small mass element, that is your dm. That is the first step that we have to do. Now, instead of following that previous method, we are following little bit different method here. And the reason being, this is a 3D problem. If I try to write it the integral, then the r will be, we have to write in the 3D. So we want to avoid it. So we take a small element, mass, delta m, which is your delta x, delta y and t, thickness t. The r, we know r, that is your center of mass, mj r vector j, rj vector divided by m. This is equal to mj, we can write sigma j multiplied by the volume, that is t delta x delta y, and r j vector divided by m. Now the sheet is uniform, so we can write sigma j, which is constant, m by v, that is mass per unit volume, m by area into thickness t. Now carry out the summation, delta x first, then delta y. It's up to you. You can carry the other way also. Now substitute. So there are certain constants which we take outside. M by at, because rho j, if you substitute m by at, t divided by m, all those constants outside. Then sigma sigma rj delta x delta y. Okay. Now what we see, that m gets cancelled, t cancels. So finally you get 1 over a, and you take limit here, delta x tends to 0, delta y tends to 0. So r vector dx dy. So beautifully we have reduced a 3D problem to a 2D problem. And because the sigma is constant, the mass is also not coming into the picture. So it is very simple till here. Now we have to go further. Now we are in the integral form. R, that is your center of mass, you can write it as x I cap plus y j cap. That is your capital X, capital Y. That is your center of mass. That is equal to 1 over a. This is your small r, which is the position vector of the small mass element. X I cap, that is a small x I cap plus small y j cap, dx dy. Then we separate I cap and j cap and write these separately. So this is your I cap and this is your j cap. This particular quantity is your capital X, that is the x component of the center of mass, and this is your y component of the center of mass. Now we will calculate them separately. That is easier, and there also we followed the same method. Fine. Now let us see. This is very, very important and lot of things to understand over here. X is equal to 1 over a x dx dy. It is the x coordinate of center of mass. Now here we consider a small strip, which is parallel to y-axis. What we need to understand here is that here it is not only dx dy, but what we are trying to do is dx dy is a small element over here. X is the x coordinate of it. We are multiplying them and adding them. It is not only dx dy, but it is a product of these two quantities. That is dx dy is the area multiplied by x and then integration of the whole. That is double integral. So that is what a very important point that we need to think about. Now, when we integrate, that is we integrating y first. Both you can do. You can integrate x first, you can integrate y first. But let us integrate y first. If I integrate y, then this is the strip I have to see. Now this strip basically, it is both when dx dy is there and I am multiplying with x. So this is the strip. Here we will integrate y first and then x. What is the limit of y? So this is another problem that we have to see, that in double integrals we have to find what is the limit of y, what is the limit of x. The first one that we are calculating is y. That is, we are integrating y. That is why we have taken a strip like this. Y is changing, x is fixed. Now, when y is changing, what is the limit of y? It is 0 to this particular line. Now, we have to find out the equation of this line. So, equation of the line, straight line will be y is equal to mx plus c. What is m? h by b. So, y is equal to h by b mx plus c, because c is 0. Once you find the equation of the line, you can find this point, that is for any x, you can find the point y. So that point will be x h by b. So we integrate and we write the quantity x dx dy 0 to x h by b. Is this clear? Now, before we go to the next integral, that is the limit of x, this particular expression is very, very important. And that is why I have written, underlined it. This is the contribution of each strip. Contribution of each strip in that double integral. That means this integral not only contains dx dy, it contains x dx dy. Alright? So, So, and the double integral of that. So that means the whole of the double integral, this particular expression is a contribution of each strip. This is a point to really ponder upon. Then finally I sum the contribution of all the strips. So once you do the y, that is y first, then you take the limit of x. At that time, what you have to do, you have to take the extreme points of x, that is your 0 to b. So 0 to b, and then you integrate. You get the answer, 2 by 3 b. Here A is the area, half B into H. So I hope this particular, so there are two particular points that one has to be very careful. What is this expression? This is the contribution of each strip in that particular integral. Try to think about it, because there actually the confusion comes, and then we are integrating it for the all x. So we are getting the value of x. That is the value of that particular integral. And then we are getting the y, and finally you get the value of r, which is 2 by 3 bi plus h by 3 j. The question comes that can one integrate x first and then y? Surely one can. But how to do it? The strip you have to take in this direction, the strip. What will be the value? If you are integrating x first, then it will be the from this particular line to this line, to this actually. What will be this line, the point? You have to find out from here in this equation. Now there, the y is constant. So you have to write in terms of y, because the y is constant. Y is constant, you have to find out the x basically. You have to find out the x. So x is equal to by h. by h. From there you have to find out this point and this point. So that is the limit of x. And then the limit of y will be your 0 to h. So that is way that you can calculate, but you must do it, and it is an assignment, so that you get the same answer both ways. Fine. Now we will go to the third problem. Now third problem I have not solved fully. So the problem is like this. A uniform plate has a shape of the region bounded by the parabola y is equal to ax square. So this is the parabola, and the equation is given y is equal to ax square, and the line y is equal to h. So bounded by this region in the xy plane. Find center of mass. So you have to find out the center of mass. So here also it is not written, but sigma is constant. Okay. Now this particular problem can be done in different methods, and there I have not solved the problem fully, but I want you to solve it so that you get a proper understanding of all these problems and the double integrals. So let us see how in different ways we can solve this problem. So just like the previous case, the first thing is that you take a small element dm, and dm is, the dimension is dx and dy. Okay. So then what you do, calculating m is very easy. You calculate integral dm sigma dy dx. Then you calculate. Now, while you calculate, you see again you have a double integral, and how will you take the limits? That is the question. How will you take the limits? So here, the first way you can do that, you can integrate x first. Alright? Integrate x first, and your y you do it later. So when you integrate x, you take y as a constant. And that is how this dotted line is shown. So this is a strip that will form the strip. Now, how will you take the limits? When you integrate x first, that means this is the way, this is the strips. what will be the limits of x? As you see, a small strip, how the limits are changing. What is the extreme lower limit and what is the higher limit? So from this point to this point. Now, what is the value of this point? How will you calculate it? You have to find out the x. So what is the x of this point? How will you find out? Because the equation of this line is given to you. From here, you can find out the x, y by a root over. So minus y by a root over 2 plus y by a root over. Now this is a symmetric function, so you can integrate basically 2 and 0 to this value. So that is the way you calculate the limits of x. Now once you take the limits of x, then you are integrating all these strips. There, what is the limit? The limit will be from 0 to, the limits of y will be 0 to h. That is how you can do it. That means when you have to calculate the center of mass. Now here, another point which is important, axiom is 0 because it is symmetric. So we see it is not it should be lying on the y axis. So x center of mass is 0, y center of mass we have to calculate. Okay, I will tell you the final answer later, but let me explain the other methods. Exactly the same way as we have done earlier, the method 2 is, now you reverse. That means you integrate y first. That is, you integrate y first. Now again you take a small dn, that is your dx dy, and then you start integrating. If you integrate y first, you have to take the limit of any strip from what is the lower limit and what is the higher limit. Now the lower limit is this, that is the lower limit of y. So that is y is equal to ax square, and what is the higher limit? Upper limit is y is equal to h. So that is the limits of y. Once you take this limit, then you have to take the limits of x. Now limits of x, as you see, it is changing from here to maximum you have to take. Maximum lower limit, maximum upper limit, because it is a smooth curve. So maximum lower limit is this one from this point to this point. So what is the point over here? Because you are taking the limit of x. X at this point is y by a root over, y by a root over. Now what is the y here? Y here is h. So h by a root over. So minus h by a root over 2 plus h by a root over. That is the limit of x. And that is how you can solve this problem. And you will get the same answer. So from these examples, what is that we learn? The thing that we learn is we can either take dx first or y first, but how to take the limits. From you have to see the strip and you have to see the limit of the strip. Then the other quantity, what is the maximum variation in the limit. So that is the method 2. Now we have a third method. The third method is little tricky in the sense that it is a symmetric problem and the xcm is 0. So it is going to lie in the y-axis. Whole body is symmetric about the y-axis. So what we do, just like our earlier cases, we take a strip of x that is 2x length and width dy. So anyway, we can calculate the mass from there, and we write dA of the strip is 2x dy. Alright, 2x dy. Then the dm will be sigma times 2x dy. Now this x we have to convert actually, because x is there and this is dy is there. So we have to convert x to y. How we can do it? We are given this equation and we will be using this equation to convert x to y. Now, the moment that is done, then these strips are done. Okay. Then the moment these strips are done, then we have to calculate we have to put the limit of y. So, what is the limit of y? Limit of y is 0 to h. Moment you do it, this is over. Is this clear to you? Fine. Then let us come to method 4. If we choose a strip, suppose say not horizontally, but a vertically, if I choose a strip. Now as you see, the things are difficult. Things are not, doesn't make sense over here. Why? Because here the things are different, because the moment I take a strip of this kind, then you see it is lying on the x is basically the y is constant for all of them, because I am calculating YCM. So for YCM, y is constant. But here the things are not like this, because when I am calculating YCM, I have to write y multiplied by dm. Now here, obviously we can calculate the mass m, but if I try to calculate the position vector of the center of mass, which is the y coordinate, then when I write y multiplied by this particular strip, that means the y of that strip, but y of that strip is changing. Here the case was different. The y of the strip was not changing. The y was constant. Here the y is changing. So it doesn't make sense. Still, you can write it mathematically. M anyway you can calculate. And how will you calculate m? This is the length y prime, and y prime is h, this is h minus this distance. So what is this distance? It is y is equal to ax square. So h minus yx square multiplied by dx integral will give you the value of, from there you can get the value of m. But the moment you try to calculate the value of your center of mass, then there is a problem. So you might try and see, if you are getting the answer. Anyway, the answer here is 3 by 5 h. You can see that YCM actually 3 by 5 h. That is your J cap. But this method will not, most probably this will not work, and don't follow it, because it doesn't make sense as well. So from these 3 examples, that means not mainly this one, from these 2 examples and also from the examples that we have seen for the triangular one, the best method is when you take the elemental mass as dx dy and then you apply the integral. This particular method applies because it has a symmetry, but most of the time this is what you have to see. So you have to see that how to take the limits. That is what you have to learn, that how to take the limits. If you are integrating x first, or if you are integrating y first, and then the vice versa. So this is mainly from these 3 examples. If you think about it, I hope it will be clear to you that how to take the limits of y and x when you take y first, when you take x first, when you take x first, when you take y first. Good. So this is mostly about the center of mass and the problems solving the center of mass using the double integrals. Now here at the end, I would like to give you a few assignment problems that you can try. The first is calculating the center of mass of a object which is basically a line. This is object, and given by the outer area, the outer circumference follows the equation y is equal to 4 minus x square within that curve. So this is the region you have to calculate the center of mass. Here it is a triangle. The vertices of the triangle, the points of the triangle given to you 0, 0, minus 4, 2, and 0.6. So you have to calculate the center of mass. Obviously, you have to find out the equation of the line, and you can take a strip, you can take dx dy, and then you can calculate. Here, it is again the first lecture that we have done, that is a hollow hemisphere whose mass is capital M and the radius is S. So, you can try and see how you can calculate the center of mass. So, that is it. But the most important thing is here that how to calculate the center of mass using the double integrals and take the limits. So, thank you very much. Hello, there is a small addition. Now, in the last part of the video, I told you that the problem of this parabola can be solved by 3 different ways, and we were discussing the last way as well, that is the method 4. In the method 4, we had taken vertical strips, and as I told you that in the vertical strips the y is changing. So if I take y dm, it doesn't make sense. The logic is not clear. But at that time it did not occur to me. We can do it in a very simple manner, and that is whenever something is changing and changing linearly, then we can take the average also. So here, this particular strip that we have chosen, we can take the average, that is a half of that strip, that is half. So what will be the half? It will be y prime by 2 plus this distance, that is your plus ax square. Then if you do the integration, that is your y is whatever that we have defined, the middle point, dm, y dm 1 over m, and integrating the integral from, this is x, so x is h by a minus root over to h by a plus root over, we will get the answer. Just now I finished this integration and I got the correct answer, so I felt like sharing that with you. So this is equally a good method, only thing is you have to take the middle point of this strip. That makes the logic very clear. Now before I end, I would like to tell you a small quote by Swami Vivekananda, which is there in my board and I see it often. What is the use of living a day or two in this transitory world? It is better to wear out than to rust out. It is better to wear out than to rust out, especially for the sake of doing least good to others, by Swami Vivekananda. Thank you very much.